Let's now go through the steps that you need to take in order to calculate a vapor-liquid equilibrium phase diagram. We're going to start things off fairly easy by looking at the case where we're dealing with an ideal solution. And so if we're dealing with an ideal solution, mathematically that just means that our activity coefficient is going to be equal to 1. And so if our activity coefficient is equal to 1, then what we get is that the partial pressure of the species I in the mixture, in the vapor phase, is just going to be equal to xi times the vapor pressure of that species. Also, if we take a look at the total pressure in the system, so P total, just to emphasize, it's just going to be equal to species 1 plus the partial pressure of species 2. And since we know that the partial pressure of each species is described by just Raoult's law here, just the regular version of Raoult's law, we could plug that in. And so we get that P is going to be equal to x1 P1 sat plus x2 P2 sat. And since we only have 2 species in the system, we know that x2 can be rewritten as 1 minus x1. Okay. All right. And so, just like you saw in MEB2, you could use this equation to relate the total pressure in the system to the mole fraction of species 1 in the liquid phase, and also the various vapor pressures. We'll call this equation 1. In order to calculate the vapor pressures of each of the species, what you would need to use is Antoine's equation, where A, B, and C are just empirical constants. Okay? Now, as far as the composition in the vapor phase, we know that the mole fraction of species I in the vapor phase, Y sub I, is just equal to the partial pressure of species I divided by that total pressure. And from Raoult's law, we know that Pi is just equal to xi Pi sat. Okay? All right, and so just using these 3 equations, one can calculate both the liquid mole fraction and the vapor mole fraction of a species in the phase diagram. Okay, and so essentially what we're going to do is we can use equations 1, 2, and 3 to prepare a PXY diagram. Okay? All right, and so essentially the algorithm we're going to take, or the algorithm that you need to follow in order to do this, is the following. Okay? And so, if you want to calculate a PXY diagram, so this is pressure here, and the x-axis is going to be for both the liquid mole fraction and the vapor mole fraction. Right? So in order to calculate this type of diagram, the first thing you would do is you would just choose an x1 value. Right? So you would calculate values at a different x1 values. And then what you would do is you'd use equations 1 and 2 to calculate the total pressure in the system. Okay, so you'd use equation 2 in order to get the vapor pressures at some particular temperature, and then you would plug in those vapor pressures into this equation, and it would give you P. Once you have P, then you could use equation 3 to calculate yi. Okay? And so to put this in graphical form, with step 2, what you would be calculating is a curve that looks like this. Okay? Where everything above this line would correspond to the pressure range in which the mixture is just pure liquid. Then with step 3, what you would be calculating is this line, where everything below this line is vapor. Okay? And the intercepts of this plot would correspond to the vapor pressures of each of the species. Okay? And so the top line here, if we're looking at P versus XY, this is our liquid line. And the line on the bottom here, this is the vapor line.